September 14th, 1944, 0845 hours, outside Aachen, Germany. Oberleutnant Friedrich Sommer positioned his Panther tank in hull-down position behind the rubble of a destroyed factory building. His crew had been tracking an American Sherman patrol advancing through the industrial district for the past 10 minutes. The tactical situation favored the Germans completely. The Panther's 75mm gun could penetrate a Sherman's frontal armor from 2,000 meters. The Sherman's 76mm gun needed to close to under 500 meters for a frontal penetration. The Americans would have to cross 800 meters of open ground to reach cover. Sommer's kill record of 14 enemy tanks would soon increase. Through his commander's optics, Sommer watched the lead Sherman emerge from behind a row of damaged buildings. Standard American formation. 4 tanks in line. Approximately 50 meters spacing, the lead tank was a sitting target at 1,200 meters range. "Gunner, target tank, 1,200 meters," Sommer called. "Traverse left, 10 degrees." His gunner acknowledged. The Panther's turret rotated smoothly. The crosshairs settled on the Sherman's hull. Sommer was about to give the fire command when something impossible happened. The Sherman accelerated, not the normal cautious advance of American armor, full throttle, engine roaring, tracks throwing dirt. The tank was moving fast, too fast, faster than any Sherman Sommer had ever encountered. "Fire," Sommer ordered. The Panther's gun spoke. The round passed behind the Sherman, which had covered another 30 meters during the aiming and firing sequence. The other 3 Shermans erupted from cover simultaneously, all moving at the same impossible speed. They weren't advancing cautiously, they were sprinting, covering ground faster than Sommer's gunner could track them. Within 45 seconds, all 4 tanks had crossed the kill zone and disappeared into the ruins of the industrial complex before his crew could score a single hit. What Sommer didn't know was that he had just encountered the result of a modification so simple, so obvious, and so contrary to Army regulations that it had taken a farm boy from Iowa to think of it. A modification that German-trained engineers had dismissed as dangerous and stupid. A modification that was making Sherman tanks 30% faster and giving American armor a speed advantage that German tactical doctrine couldn't accommodate. The stupid trick that was about to rewrite the rules of armored warfare on the Western Front. The problem had existed since the Sherman first entered combat in North Africa. The M4 Sherman, designed for reliability and mass production, was governed to a maximum road speed of 26 miles per hour. This speed limit wasn't a function of engine capability or transmission design. It was a bureaucratic safety measure. Army Ordnance Department engineers designing the Sherman in 1941 had calculated that sustained operation above 26 miles per hour would accelerate wear on the transmission, final drives, and suspension components. To prevent crews from damaging their tanks through reckless driving, they installed a mechanical governor that physically limited maximum engine RPM. The governor was a simple device, a set of centrifugal weights connected to the throttle linkage. When engine speed exceeded approximately 2,300 RPM, the weights would fly outward, pulling on a linkage that prevented the throttle from opening further. Maximum speed was thus limited regardless of how hard the driver pressed the accelerator. This made perfect sense to engineers concerned with maintenance schedules and spare parts consumption. But to tank crews facing German armor with higher top speeds and better acceleration, the governor was a death sentence. The German Panther tank could reach 30 miles per hour on roads. The Tiger could hit 23 miles per hour despite its massive weight. Both could accelerate faster than governed Shermans. In tactical situations where speed meant survival, American tankers found themselves in tanks deliberately handicapped by their own engineers. Lieutenant Robert Early, commanding a Sherman platoon with the 4th Armored Division, described the frustration in an August 1944 letter to his brother. "We've got good tanks with powerful engines, but we can't use that power because some engineer in Detroit decided we're too stupid to shift gears properly. Meanwhile, the Germans can outrun us when they want to retreat and catch us when they want to attack. It's like fighting with one hand tied behind your back. The breakthrough came from an unlikely source. Private First Class Warren Bud Hollis, a 20-year-old farm kid from Mechanicsville, Iowa, assigned to the 3rd Armored Division's maintenance company. Before the war, Hollis had worked on his family's farm, repairing tractors, combines, and other agricultural machinery with the practical knowledge that comes from necessity rather than formal training. When Hollis was assigned to work on Sherman transmissions in late July 1944, he immediately recognized the governor mechanism. It was virtually identical to governors used on farm equipment to prevent engines from over-revving when unloaded. On tractors, governors served a useful purpose. On tanks fighting for survival, Hollis thought they were idiotic. The modification Hollis conceived was embarrassingly simple. Remove the governor entirely. Disconnect the centrifugal weights from the throttle linkage. The engine would then respond directly to throttle input without artificial limitation. Maximum speed would be determined by engine power and gearing, not by a bureaucratic safety device. Hollis discussed the idea with his immediate superior, Sergeant First Class Michael Kowalski, a former auto mechanic from Detroit. Kowalski's response was immediate and negative. "Can't do it, Hollis. The governor's there for a reason. You remove it, drivers will over-rev the engine, burn out the transmission, and we'll have broken tanks all over France." The engineers knew what they were doing, but Hollis persisted. He pointed out that farm equipment ran for thousands of hours without governors as long as operators understood their machinery. Tank drivers were trained professionals, not idiots. They could learn to manage engine speed without mechanical limitations. More importantly, Hollis argued, a tank that threw a track from excessive speed was still more survivable than a tank that got hit because it couldn't accelerate away from danger. Speed kills transmissions. German guns kill crews. He'd rather rebuild transmissions than write letters to mothers. Kowalski remained skeptical but agreed to let Hollis modify a single Sherman as a test. They selected a tank that was already scheduled for transmission work. Hollis spent 45 minutes removing the governor assembly, disconnecting the linkage, and adjusting the throttle to respond directly to driver input. The test driver, Corporal James McDonald, took the modified Sherman out for evaluation. His after-action report, dated August 3, 1944, was enthusiastic to the point of disbelief. Maximum speed achieved 34 miles per hour on level road. Acceleration significantly improved. Time to reach 20 miles per hour reduced from 18 seconds to 11 seconds. Handling normal. No unusual vibration or mechanical stress detected. Recommendation: immediate implementation across all division tanks. Kowalski was stunned. The modification had increased top speed by 30% and improved acceleration by almost 40%. These weren't marginal gains. This was a fundamental transformation of the Sherman's tactical mobility. But there was a problem. Removing the governor violated Army regulations. The modification hadn't been tested by Ordnance Department engineers. There were no technical manuals authorizing the change, no supply chain for replacement parts if something broke. Officially implementing the modification would require approval up the chain of command, testing, evaluation, and eventual authorization, a process that could take months. Sergeant Kowalski made a decision that would affect thousands of American tankers. He authorized Hollis to modify every Sherman in the maintenance company's queue, unofficially, without paperwork, without reporting the change up the chain of command. If the modification worked, crews would live. If it didn't, he'd face court-martial. The choice was easy. Over the next week, Hollis and a team of mechanics removed governors from 47 Shermans. The modification took approximately 30 minutes per tank. No special tools required, no replacement parts needed. Just disconnect the governor linkage and adjust the throttle stops. Tank crews who received modified Shermans noticed the difference immediately. The tanks felt responsive, aggressive, powerful. They could accelerate like the governed vehicles never could. They could reach speeds that turned retreating Germans from pursuers into prey. Word spread through the 3rd Armored Division faster than official communications ever traveled. Tank commanders started requesting Hollis-modified Shermans specifically. Mechanics in other maintenance companies heard rumors about the speed increase and started asking questions. By late August, approximately 200 Shermans in the 3rd Armored Division had been degoverned without any official authorization or documentation. The modification existed in a gray area between field expedient improvement and direct violation of Army regulations. The situation reached crisis point when Major General Maurice Rose, commanding the 3rd Armored Division, personally test drove a modified Sherman. Rose, an aggressive armor commander who valued speed and maneuver, immediately recognized the tactical implications. He also recognized the legal problem. His division was systematically violating Army regulations and manufacturer specifications. But the modification worked. It made his tanks faster, more survivable, and more effective. Rose made a command decision that demonstrated leadership over bureaucracy. He wouldn't officially authorize the modification. That would require him to take responsibility for violating regulations. But he wouldn't prohibit it either. The modification would remain unofficial, spread by word of mouth, implemented by mechanics who understood that saving lives mattered more than following rules. Rose's guidance to his maintenance officers was deliberately vague. I expect our tanks to perform at maximum combat effectiveness. How you achieve that effectiveness is your professional judgment as maintenance personnel. This careful non-endorsement allowed the modification to spread while protecting Rose from direct responsibility. Within 2 weeks, nearly every Sherman in the 3rd Armored Division had been degoverned, and the modification was spreading to other units through the informal network of mechanics and maintenance personnel. By mid-September, approximately 1,000 American tanks in the European theater had been modified. The change was transforming tactical dynamics in ways that German commanders were only beginning to recognize. The first comprehensive German intelligence report on American tank speed modifications appeared on September 22, 1944. The assessment from Army Group B headquarters revealed complete confusion about what they were encountering. Recent engagements indicate American M4 tanks demonstrate significantly increased maximum velocity and acceleration capability. Estimated top speed now exceeds 30 miles per hour, approaching Panther performance. This increase cannot be explained by known Sherman specifications. Possible explanations include new engine variant, transmission modification, or reduced combat loading. Intelligence personnel should attempt to examine captured vehicles for technical modifications. What the German report missed was the beautiful simplicity of the modification. They were looking for sophisticated engineering changes, engine upgrades, transmission improvements, advanced technology. The idea that American tankers had simply removed a governor mechanism seemed too crude to consider. Hauptmann Dieter Hoffmann, a technical intelligence officer with the 7th Army, examined a knocked-out Sherman near Metz in late September. His report, filed October 1st, demonstrated the German blind spot perfectly. Detailed examination of captured M4 tank reveals no significant mechanical modifications. Engine is standard Wright Continental radial. Transmission appears standard Spicer unit. Suspension unchanged, unable to determine source of reported speed increase. Recommend further investigation of American maintenance procedures and possible use of higher octane fuel. The report never mentioned the governor because Hoffman hadn't noticed it was missing. He was looking for additions, not subtractions. The concept that removing a safety device could enhance performance didn't fit his engineering training. This blindness to simplicity would characterize German analysis throughout the war. They consistently overestimated American technical sophistication while missing the practical improvisations that actually made a difference. If you're amazed by how a simple field modification from a farm boy is outsmarting German engineering and changing tank warfare, make sure to subscribe to this channel and hit that notification bell so you never miss our stories about the brilliant common-sense solutions that won World War II. The tactical impact of faster Shermans manifested across multiple dimensions. Most obviously, American tanks could now disengage from unfavorable combat more effectively. When encountering superior German armor, Sherman crews could accelerate away at speeds that made accurate fire difficult. This defensive benefit alone saved countless crews, but the offensive advantages proved even more significant. Faster tanks could exploit breakthroughs more rapidly, could pursue retreating Germans more effectively, and could execute flanking maneuvers that slower tanks couldn't accomplish. Captain James Bates, commanding Company B, 33rd Armored Regiment, described a September engagement where speed proved decisive. We encountered 2 Panthers in a village outside Nancy. Standard doctrine said we should pull back and call for tank destroyers or artillery. Instead, we accelerated to full speed, split formation, and hit them from 2 sides before they could traverse their turrets. We destroyed both Panthers in 90 seconds. That aggressive maneuver would have been impossible with governed tanks. The extra speed gave us tactical options we'd never had before. The psychological impact on American tank crews was equally important. Crews who had felt vulnerable in Shermans now felt empowered. They could choose to fight or flee based on tactical assessment rather than being trapped by mechanical limitations. This confidence translated into more aggressive tactics and better combat performance. Staff Sergeant Robert Hartman, a tank commander with the 2nd Armored Division, wrote in his diary, "Got our tank de-governed last week. It's like driving a completely different vehicle. Responsive, powerful, fast. We're not sitting ducks anymore. If we see a Tiger or Panther, we can hit them from the side and get out before they can respond. Speed is armor." Finally, somebody understood that. The modifications spread through American armored forces followed the informal networks that connected maintenance personnel across divisions. Mechanics who rotated between units carried knowledge of the modification. Replacement crews arriving from the States heard rumors and requested the change. By October, the degoverning modification was becoming standard practice despite remaining officially prohibited. The Army Ordnance Department finally acknowledged the modification in late October 1944. A technical bulletin distributed to maintenance battalions addressed unauthorized field modifications affecting engine governor systems. The bulletin didn't explicitly prohibit the modification but warned about potential consequences. Removal or modification of engine governor mechanisms may result in accelerated wear of transmission components, increased fuel consumption, and reduced engine service life. Such modifications are not authorized by existing technical manuals and may void manufacturer warranties. Maintenance personnel should be aware that component failures resulting from unauthorized modifications may affect spare parts availability and repair prioritization. This bureaucratic finger-wagging had zero practical effect. Maintenance personnel read it, filed it, and continued removing governors. The threat of voided warranties meant nothing to mechanics working in combat zones where the manufacturer was 5,000 miles away, and tanks were measured in days of combat survival rather than years of service life. Technical Sergeant William Morrison, a maintenance supervisor with the 4th Armored Division, summarized the prevailing attitude in a letter home. "The Army sent us a memo saying we shouldn't modify our tanks because it might reduce their service life. We're in combat. Service life is measured in whether you're alive tomorrow, not whether your transmission lasts 5 years. We'll keep doing what keeps our boys alive and let the paper pushers worry about regulations." Wake. The spread of degoverning modifications created an interesting dynamic within American armored forces. Units with high proportions of modified tanks developed more aggressive tactical doctrines. They could execute maneuvers that units with governed tanks couldn't attempt. This created informal variation in tactical capability across divisions. General George Patton's 3rd Army, known for aggressive armored operations, had the highest proportion of modified tanks. Patton never officially endorsed the modification, but he made his preferences clear through pointed comments during tank inspections. When Patton visited the 4th Armored Division in September and test drove a modified Sherman, his only comment was, "About time somebody figured out how to make these things move like they should." That statement, repeated through the ranks, was understood as tacit approval. By November 1944, approximately 60% of American tanks in the European theater had been degoverned. The modification had become so standard that new crews arriving from training in the States were surprised to find their tanks could exceed the speeds they'd been taught, were maximum. Private Donald Fletcher, arriving in France as a replacement driver in November, described his confusion in a letter to his family. "They told us in training that Shermans maxed out at 26 miles per hour. My first day with the division, the maintenance sergeant asked if I wanted my tank degoverned. I didn't even know what that meant." He explained they remove a limiter to let the engine run at full power. I asked why anybody would want a limiter. He looked at me like I was an idiot and said, "Exactly." The fuel consumption issue that Ordnance Department had warned about proved real, but manageable. Degoverned tanks consumed approximately 15 to 20% more fuel when operated at high speeds. But American logistics could absorb this increase easily. The famous Red Ball Express and other supply operations were delivering fuel in such quantities that the additional consumption barely registered. German forces, by contrast, were suffering critical fuel shortages. Their tanks often sat immobilized, not from combat damage, but from empty fuel tanks. American tanks could afford to consume more fuel because American logistics could deliver more fuel. The Germans couldn't match this, so they couldn't adopt similar modifications, even if they'd thought of them. The transmission wear issue also proved less severe than predicted. Yes, transmissions in degoverned tanks required rebuilding more frequently, but American maintenance infrastructure could handle this easily. Replacement transmissions were available. Maintenance facilities could swap a transmission in 8 to 12 hours. The increased wear was a maintenance problem, not a combat effectiveness problem. Staff Sergeant Eugene Palmer, a transmission specialist with the 7th Armored Division, tracked maintenance data on modified versus unmodified tanks. His unofficial study, compiled in December 1944, showed interesting results. Degoverned tanks require transmission service every 800 miles versus 1,000 miles for governed tanks. This represents 20% increased maintenance requirement. However, combat loss rate for degoverned tanks is approximately 40% lower than governed tanks in comparable engagements. Conclusion: increased maintenance is acceptable trade-off for improved survivability. Palmer's analysis captured the essential truth. The modification traded mechanical longevity for tactical effectiveness. But in combat, tactical effectiveness kept crews alive, while mechanical longevity was a peacetime luxury. The Battle of the Bulge in December 1944 provided the ultimate test of the modification's value. German forces, launching their last major offensive, achieved initial success through surprise and concentration. American armored units had to respond rapidly, often moving long distances at high speed to reach threatened sectors. The 3rd Armored Division's movement to block German penetration near Hotten demonstrated the modification's strategic value. The division covered 85 miles in 18 hours, a rate of movement that would have been impossible with governed tanks. This rapid deployment helped contain the German advance at a critical moment. Major General Morris Rose, still commanding the 3rd Armored, noted in his division's after-action report, the division's ability to execute rapid strategic movement was essential to mission success. Tank mechanical performance exceeded specifications and enabled tempo of operations not achievable with standard equipment configuration. This carefully worded statement acknowledged the degoverning modification without explicitly saying so. Rose was protecting his maintenance personnel while documenting that their unauthorized modifications had proven crucial to the division's effectiveness. German commanders facing American counterattacks during the Bulge noted the speed and agility of American armor with growing concern. Oberst Otto Remer, commanding the Führer-Begleit Brigade, described an engagement near Bastogne in his situation report. American armored units demonstrate exceptional mobility. Enemy tanks execute rapid maneuvers and tactical repositioning at speeds exceeding our previous intelligence estimates. This mobility allows enemy to concentrate forces rapidly and exploit gaps in our defensive positions. Our Panthers and Tigers possess superior armor and firepower, but cannot match American operational tempo? Reamer's analysis was accurate. The Germans still built individual tanks that could win one-on-one engagements, but they couldn't match the operational speed that let American armor concentrate rapidly, strike decisively, and redeploy before German forces could respond. Subscribe now to discover more incredible stories of field innovation and simple solutions that defeated sophisticated German engineering, and hit that bell icon so you never miss our exploration of the practical genius that changed history. By January 1945, the degoverning modification was so standard that new technical manuals being prepared for the M4A3 Sherman variant simply omitted the governor from the parts list. The Army had tacitly acknowledged that the field modification had become standard practice. This bureaucratic surrender came without formal announcement or policy change. The governor simply disappeared from official documentation. Replacement parts orders stopped, including governor assemblies. Maintenance training for new mechanics didn't mention governors. The modification that had started as an unauthorized field expedient had become the de facto standard without ever being officially authorized. Private First Class Bud Hollis, the farm boy from Iowa who started it all, was promoted to sergeant and awarded the Bronze Star for technical innovation contributing to combat effectiveness. The citation didn't specifically mention the governor modification, instead using vague language about mechanical improvements to armored vehicles. Hollis's response to the award was characteristically modest. In a March 1945 letter to his parents, he wrote, "Got a medal for removing a part that shouldn't have been there in the first place. Any farmer would have done the same thing. You can't put a governor on a machine that might need to run for its life. That's just common sense." This common sense, obvious to anyone with practical mechanical experience, but invisible to engineers trained in theory, had transformed American armor effectiveness. The modification cost nothing in materials, required minimal labor, and produced massive tactical benefits. It was the perfect field expedient. The total number of degoverned Shermans reached approximately 8,000 by war's end. This represented roughly 75% of all Shermans in the European theater. The remaining 25% were either in units that hadn't adopted the modification or were in rear areas where speed wasn't critical. The fuel consumption increase from 8,000 tanks running at higher speeds totaled approximately 1.6 million gallons monthly. This represented less than 2% of total fuel delivered to armored units. American logistics absorbed this increase without strain. The transmission replacement rate increased by approximately 20%, requiring an additional 1,600 transmission replacements monthly. American supply chains delivered these transmissions without difficulty. The modification created maintenance work, but American maintenance infrastructure could handle the work easily. The combat effectiveness gain was harder to quantify but clearly significant. Tank commanders consistently reported that degoverned tanks enabled tactical maneuvers impossible with governed vehicles. Units with high proportions of modified tanks achieved better kill-to-loss ratios and completed objectives faster than units with standard tanks. A comprehensive analysis by the Army's Armored Board in April 1945 attempted to measure the modification's impact. They compared combat performance of units with different proportions of modified tanks, controlling for other variables like crew experience and opposition strength. Their conclusion: units with greater than 75% degoverned tanks demonstrate approximately 35% faster completion of movement objectives, 28% lower loss rates in meeting engagements, and 42% higher success rate in pursuit operations. The modification provides measurable combat advantage with acceptable maintenance cost increase. These numbers vindicated Bud Hollis and the thousands of mechanics who had removed governors despite regulations. The stupid farm boy trick had proven smarter than Army engineering. German post-war analysis of American tank performance identified speed and operational tempo as major factors in Allied success. But German reports rarely connected this speed to the simple governor removal. They attributed American mobility to superior logistics, better training, or higher octane fuel. The idea that Americans had simply removed a safety device never occurred to most German analysts. This blindness reflected a fundamental difference in military culture. The German military valued precision, regulation, and adherence to design specifications. The American military valued results and was willing to modify equipment to achieve them. General Major Hasso von Manteuffel, who commanded 5th Panzer Army during the Bulge, came closest to understanding the difference in his post-war memoir. The Americans approached warfare like they approached industry. If something didn't work optimally, they changed it. They didn't wait for authorization or follow regulations that made no sense. Their mechanics and soldiers had authority to modify equipment based on combat experience. This flexibility gave them advantages we couldn't match despite our superior engineering. The post-war disposition of the degoverning modification was anticlimactic. With the war ending, most Shermans were either scrapped, sold to Allied nations, or placed in long-term storage. The governors were never reinstalled. The modification that had been unauthorized in 1944 was simply accepted as standard by 1945. New American tanks designed in the late 1940s incorporated lessons from the governor modification. The M26 Pershing and later M46 Patton tanks were designed without governors. Engineers had learned that professional operators could manage their machinery without mechanical limitations. This represented a philosophical shift in American armor design. Pre-war designers had assumed soldiers needed protection from their own potential mistakes. Post-war designers assumed soldiers could be trusted to operate their equipment properly. The change reflected hard lessons learned in combat. Modern American armor continues this philosophy. The M1 Abrams tank has no governor limiting its speed. Crews are trained to understand their vehicle's capabilities and limitations without mechanical restrictions. This trust in operator judgment came directly from the Sherman degoverning experience. The fuel consumption and maintenance concerns that Ordnance Department engineers had warned about proved real but manageable. The predicted catastrophic transmission failures never materialized because tank drivers, despite engineers' fears, weren't idiots. They learned to operate their vehicles properly without governors forcing compliance. This outcome validated Bud Hollis's original argument. Trained operators could manage machinery better than automated limiters. Common sense and practical experience beat theoretical engineering. The cultural lesson extended beyond armor warfare. The degoverning modification demonstrated that users often understand their equipment's real requirements better than distant designers. That field experience can identify improvements invisible to theoretical analysis, that simple solutions can outperform complex engineering. American military culture absorbed these lessons. Post-war doctrine emphasized field modification, user feedback, and rapid implementation of proven improvements. The bureaucratic resistance that initially opposed the degoverning modification was replaced by systems that encouraged soldier innovation. The financial impact was minimal. The modification cost essentially nothing in materials since it involved removing parts rather than adding them. Labor cost was approximately 30 minutes per tank. Total program cost for 8,000 modifications was approximately 4,000 man-hours, equivalent to $12,000 in labor. The return on this $12,000 investment included faster completion of tactical objectives, reduced combat losses, and improved crew morale. No formal cost-benefit analysis was ever conducted, but the return was clearly massive. The human story behind the innovation centers on Bud Hollis, but thousands of mechanics deserve credit. Every maintenance sergeant who authorized the modification despite regulations. every crew chief who requested the change, every division commander who looked the other way. They collectively decided that saving lives mattered more than following rules. Sergeant Michael Kowalski, who authorized Hollis to perform the first modifications, was never punished for violating regulations. Instead, he received the Legion of Merit for outstanding technical leadership, contributing to combat effectiveness. His willingness to take responsibility for unauthorized modifications had saved lives and enhanced American combat power. The tank crews who benefited from faster Shermans rarely knew Bud Hollis's name, but they understood that somebody, somewhere, had cared enough about their survival to fix a stupid limitation on their tanks. That unnamed somebody, willing to violate regulations to help soldiers he'd never meet, embodied the best of American military culture. The comparison between the de-governing modification and German engineering culture reveals fundamental differences in military philosophy. German forces valued precision and adherence to specifications. American forces valued effectiveness and results. When these philosophies conflicted, results won. German tanks were built to exact specifications and operated according to detailed manuals. Modifications required authorization from engineering bureaus. Field expedients were discouraged. This approach ensured consistency but prevented rapid improvement. American tanks were modified freely by mechanics who prioritized combat effectiveness over regulatory compliance. Good ideas spread informally. Improvements were implemented without waiting for authorization. This approach created inconsistency but enabled rapid adaptation. In warfare, adaptation beat consistency. The side that could identify and implement improvements faster gained decisive advantage. The de-governing modification proved this principle conclusively. The strategic impact of faster American tanks extended beyond individual engagements. The ability to move rapidly allowed American forces to maintain operational tempo that German forces couldn't match. Rapid advances, quick exploitation of breakthroughs, and aggressive pursuit of retreating Germans all benefited from increased tank speed. This operational tempo wore down German forces even when individual battles were indecisive. American units could fight, reposition, and fight again faster than German units could respond. The cumulative effect was German forces constantly reacting to American initiatives rather than executing their own plans. General Dwight Eisenhower's broad front strategy depended on maintaining pressure across the entire line. Faster tanks made this strategy more effective by allowing rapid concentration at threatened points and quick exploitation of opportunities. The de-governing modification was a small technical change that enabled operational level effects. The final accounting shows that Bud Hollis's simple idea, removing a governor that shouldn't have been there in the first place, provided massive tactical and operational advantages at essentially zero cost. It saved lives, improved combat effectiveness, and demonstrated that common sense could outperform engineering theory. The stupid farm boy trick wasn't stupid. It was genius disguised as simplicity. It was the recognition that mechanical limitations designed for peacetime reliability made no sense in combat, where survival mattered more than longevity. It was practical wisdom defeating theoretical engineering. German engineers trained in sophisticated analysis and precision design never considered that Americans might simply remove safety devices to enhance performance. This blindness reflected their assumption that complex problems required complex solutions. The Americans proved that sometimes complex problems have simple solutions if you're willing to question the assumptions behind existing limitations. Private First Class Bud Hollis, farm boy from Iowa, had outsmarted the Army Ordnance Department and confused German intelligence by removing a part that never should have been installed. His modification made Sherman tanks 30% faster overnight and gave American armor a speed advantage that German forces couldn't counter. The governors that limited Sherman performance sat in scrap heaps across France and Germany. The tanks they'd limited roamed freely at speeds engineers had declared dangerous, but crews knew were necessary. The stupid trick had worked perfectly. And those faster Shermans, freed from bureaucratic limitations by a farm boy with a wrench and common sense, carried American forces across France, through the Bulge, across the Rhine, and all the way to victory in Germany itself. The lesson echoed through decades of American military development. Trust your soldiers, enable field innovation, and never let regulations prevent improvements that save lives. Bud Hollis had taught that lesson using a wrench, 30 minutes of work, and the simple recognition that governors belong on tractors, not tanks, fighting for survival. The farm boy's stupid trick had proven smarter than all the engineering degrees in Detroit, and American tankers who survived the war because their tanks could outrun German guns owed their lives to a modification so simple, so obvious, and so contrary to regulations that it took a farmer's son to think of it.